Okay, so we're going to find an inverse of this function that they give us. Now, we haven't really talked too much about, oh, it has to be a one-to-one function. I mean, we mentioned it, but how do we know this is a one-to-one function? Well, this is from our toolkit functions, and we know what it looks like, basically. We know it's going to be, a cubic function, right? Something like that, except it's going to have a stretch factor, so it's going to be really skinny, and the whole thing's going to be shifted up one. So it probably looks, something like a really skinny S-shaped curved, something like that, and it goes through, oops, it only shifts up one. I don't know why I was shifting it up so high, but something like that. So it is one-to-one. Okay, so we're going to be able to find the inverse, and we're going to follow the steps for finding an inverse. So let's write it as y equals 5x cubed plus 1. Switch x and y. And then we're going to solve for y. So the way we want to solve for y is subtract the 1. And then you'll need to divide by the 5 first. So you have x minus 1 over 5 equals y cubed. But you can take the cubed root of both sides. So make sure you put that index in there. It's a cubed root, not a square root. Make it look like a 3. Okay, and then we're going to have, I'll just come over here and write y equals the cubed root of x minus 1 over 5. But then we're going to put in the inverse notation. So inverse, f inverse of x equals the cubed root of x minus 1 over 5. And if you wanted to see what those look like, I'm going to show you some pictures on some other problems we're going to do, but they do have a nice picture in the book of the function and its inverse. Okay.